Good morning, Mr. Chan here for Algebra 1. We're about to do lesson 4-1, solving systems of equations by graphing. Please grab your note taker, your student companion, and turn to page 75. We are actually going to skip this morning the first opener, the page. So we'll just go on to the next section here. So we'll just don't worry about this part, and so on and so forth. All right. So the title, Solving Systems of Equations by Graphing, is referring to what would happen if you graph lines on top of each other on a coordinate plane. Off to the left here, we're going to be focusing on something traditional, the slope-intercept form of a line. Here it is. Y equals mx plus b should look very, very familiar. As you know, we are dealing with two variables, x's and y's, and the coefficient in front of the variable x is called the slope. That, of course, describes how steep or how shallow the line is graphed. And then the number by itself, b, is the y-intercept. This is where the line crosses the y-axis. And we'll be dealing with that today. Sometimes the equations of linear functions are given to you in standard form. When they're given to us in standard form, we want to probably use x and y intercepts to graph it. The other option is to convert it to slope-intercept form. That takes some work as well. Standard form is ax plus by equals c. The strategy is to find the x-intercept first by setting y equals 0. This is stuff we've already done before. And then connect it to the other intercept, the y-intercept, by setting x equal to 0. These are the two strategies we're going to be using today to see how we graph a pair of lines. Before we actually do the actual problems, let's talk about the three scenarios that can happen when you graph lines. Scenario number one, you might have something like this, where two lines intersect at one spot. This is considered to have one solution. Fair enough. Scenario number two, you graph a line and then a second line, and you notice they don't cross at all. In geometry, we put in some arrowheads on the lines themselves to show that they are parallel. This is where they don't cross at all. So this is known to have no solution because they have the same slope and they are parallel. They do have different y-intercepts, meaning where they cross the y-axis right there and right there. Finally, there's a third possibility that can happen. What happens if you graph two lines and they are on top of each other? This is considered to have infinite solutions. We know that symbol, the sideways 8, is infinite, meaning all the values are the same. This is because it's the same line. So those are the three scenarios that we have for today, and that's pretty much basically it. Graphing is one of those strategies that we do to solve for that. All right, let's go and get going here. Zoom in a little more. Number one, we have a couple of equations in slope-intercept form. We're going to go ahead and kind of eyeball it. I noticed right away, though, the y-intercepts happen to be kind of in the negative territory. So let me give myself some more room towards the bottom of the graph by adjusting the axes. Go ahead and draw your axes like that. That gives me some room to place those y-intercepts. It's kind of like a good way to judge how you're going to graph these things. First equation, the slope is 1/2. While its y-intercept is -2, let's go ahead and put that somewhere. -2 is right there for the first equation. The slope is 1/2. So rise 1 over 2, up 1 over 2, up 1 over 2. So there's my first. You can see it crosses the y-axis at -2 and has a positive slope of 1 over 2. Let's connect those dots. Yay. The second graph has a y-intercept of -7. 3, 4, 5, 6, 7. And its slope is 3. Now you got to convert that to a fraction, 3 over 1. And that represents 3, the whole number. So let's rise 3 over 1. Up 3 over 1. Oh, there it is. Rise 3 over 1. Boom. This particular system intersects each other in one spot. This is considered to have one solution. That one solution is 2, -1. Yay. That is one solution. Any questions about 1A? All right, we're going to do the same thing with 1B. Again, first thing you want to look at are the y-intercepts and kind of gauge the axes you need to adjust with. So I have a 10 and a 1. Boy, I'm going to need as much as I can. So let's adjust the x-axis all the way down there. And then I'll just write my y-axis right there. All right. We have the slope of 2 over 1 for the first equation. So let's go ahead and start that. The y-intercept is 10. Wow, all the way to the top there, that's 10. Its slope is 2 over 1. Up 2 over 1 is way up here. Let me walk backwards, down 2, left 1, down 2, left 1, down 2, and just apply it backwards that way. There's my first graph of the line, 2x plus 10. Next equation, I have a y-intercept of 1. Its slope is -1/4. Now be careful there. That negative sign should be applied to one of those numbers, but not both. If you apply it to both of them, it would be a double negative, which makes it positive, and you're applying one extra too many negatives. So apply to one of them, it doesn't really matter. -1 over +4 is the same as +1 over -4, which I'll show you in a second here. So let's do -1/4 first, down 1 over 4. Okay, versus up 1 over -4. It's the same line. There it is. There's my intersection. Bam. That particular intersection is -4, +2. And that's your answer. I know this is an Algebra 1 class, but sometimes you might be able to check maybe with some graphing calculators or even Desmos. So what I'm going to do is to switch over to Desmos. Remember these two answers, 2, -1, and -4, 2. If we switch over to Desmos, I already have 1A ready to go here. Boom, boom, there it is. Let me just check here. There it is, 2, -1. Yes, that's the answer we got for number 1A. Switch those off. Let's check 1b. Oh, there it is. -4, 2. So that works right there as well. Sometimes it's nice to have technology to check your answers. It's not really cheating. It's just a good way to see what you're doing here, okay? All right. Let's move on to example 2. Any questions about example 1? All right. We're just going to keep going. But this time we have some strange things that will happen. They kind of give it away already. What would happen when you have a system with infinitely many or no solutions? So you know what's coming up, folks. We have a couple equations here for number 2a. We have y equals 1/2 x plus 7. And we have another one at 4x minus 8y equals 12. That's kind of a pain, the second one. We're going to have to use intercepts for that one. But to kind of give you guys an idea, we do need to adjust our axes. And I'll help you out and focus on the first quadrant. So there are my x and y axes. And for the first one, I'm going to go ahead and plot that. The y-intercept is, of course, 7. Let's do that. There's my 7. My slope is 1. Oh, I might have to go by 2's, looks like. Yes, I just realized that. So let's go by 2's here to account for all these big numbers here. So my y-intercept is 7, 2, 4, 6, 7 right there. Its slope is 1/2. So up 1 over 2, up 1 over 2, up 1 over 2. So there's my first equation right there, graphed. Second one is in standard form. So perhaps we should probably focus on intercepts. The technique is to concentrate on the x-intercept first by setting y equal to 0. And let's see what we get here. Plug in 0 for y. That clears that out. 4x equals 12. Divide by 4 to both sides. X equals 3. So on the x-axis, go to 3, put a dot there. Okay, that's your x-intercept. For the y-intercept, set x equal to 0. When you do that, this zeroes out, leaving with -8y equals 12. Divide through by -8. Oh, we're going to get a fraction, folks. We're going to get 12 over -8. That reduces to negative, if we divide top and bottom by 4, 3/2, or simply -1.5. So on the y-axis, go to -1.5, which is right there. I suspect these might be parallel lines. In fact, I'm going to go ahead and invoke Desmos and see what they say for example 2a. So here we go. First line, second, oh, there it is. No matter how far I zoom out or zoom in, they look like they do not intersect at all. They are definitely parallel. All right, very cool. So in this case, if they're parallel, they'll never cross, which means there is no solution. All right. Letter B. Looks like I could use intercepts for the first equation. Unfortunately, that's going to be ugly. I'm going to get like fractions again. So maybe perhaps we can try to rearrange the first equation. Here we go, 3x plus 2y equals 9. Let's go ahead and divide by 3 to everything. Let's do that first. And when I do that, I get x plus 2/3 y equals 3. After you cancel those 3's and reduce that one right there, very good. Now this is kind of interesting. I'm looking at the second equation, it looks like it's all the same. Look at that, 2/3 y on the left side by itself. What if I move the x in my first equation to the other side? What would happen? Let's subtract x to both sides. And lo and behold, interestingly enough, in this particular problem, that equation, the first equation, is the same. Same line. Which means my answer is infinite solutions. If I take a look at Desmos, let's see if they agree with me. Turn off the previous example, turn on those two, 3x plus 2y, and 2/3 y equals 3 minus x. Oh, look. You can barely see it, but we have a blue line for the first equation and a green line on the second one. It's the same exact line. All right. Nice. Let's continue on. Any questions about this page? Let's move on to the next page. These are all word problems that are not on the final. They're not part of the curriculum. We're going to skip this page right here entirely and move on to the last page. Here we go. Solve each equation for number 5 by graphing. Oh, yay. They're already in slope-intercept form. Very nice. The hard part sometimes is to adjust the axes. Looks like I have a 5 and a 0 for my y-intercept, so I don't really have to worry too much for this particular problem. Let's graph the first one. Y-intercept, of course, is 5. Let's put a dot there. Its slope is 2/1. So up 2/1 is right there. I'm going to walk it backwards, down 2 left 1, down 2 left 1. I'm just walking it backwards. All right, great. The next equation is y equals -1/2 x plus 0. Technically, 0 is right there. That's my y-intercept. My slope is -1/+2 or 1/-2. It's all the same. So -1/2, down 1/2, down 1/2, and up 1/2. The nice thing about this section is that the intersections are usually nice and whole numbers. In this case, they intersect at -2, +1 is my solution. Has one solution. Any questions? Graphing is just one of the many techniques that are out there when it comes to solving systems, and it's nice when the numbers come out nice and whole. When they come out fractions or radicals, it's not the best choice to solve systems, okay? All right, let's move on to number 6. Number 6, we're going to use intercepts for the second equation. The first equation looks like we can do regular y equals mx plus b. All right, here we go. The y-intercept is, of course, 2. Let's go and highlight that on the y-axis, and the slope is -2/3. Down 2/1. Sorry, down 2/3. Misspoke there a little bit. Connect the dots. Whoa. Very nice. That's the first equation. Second equation, I'm going to use intercepts to solve it. For the x-intercept, I want to set y equal to 0. This is the technique now. So 2x plus 3 times 0 equals 6. That zeroes out right there. And to solve the rest of the problem, you divide by 2 to both sides. X equals 3. Yay, there it is. Got lucky there. X equals 3. Boom, there's my answer right there. Pretty much. Let's make sure that's not parallel lines though. Let's figure out what's going to happen with the y-intercept. Set x equal to 0. Let's do it. 2 times 0 plus 3y equals 6. That zeroes out. Divide by 3, the coefficient there, and I'll get y equals 2. Go to the y. Oh, whoa. I think I was right. Look at that, folks. Ladies and gentlemen, we have a situation where it's the same line, which means this has infinite solutions. Interesting. What? So let's verify that with our Desmos here. The first one was -2, 1, and the second one is infinite solutions. Interesting. Here we go, let's check it. So number 5 was this guy, 2x plus 5 and -1/2 x. Yep, there it is, folks, -2, 1. And the last problem, same line, look at that. Same line. Very good. All right. I think we are satisfied. We are not going to do the word problem at the bottom there. Are there any questions? If there aren't any, well, have a good day. And I'll see you next time. Thanks a lot. Bye-bye.